When it comes to mathematics, what are the two most dreaded words? Give up? Word problems. Yuck! The very name may even make you break out in a cold sweat and begin to get nauseous. And why? Because you are afraid that you cannot do word problems. That's utter nonsense. Of course you can do word problems. Half of your trouble with word problems is that you're afraid of them. The other half of the problem is that you don't think when you are reading a word problem. You don't look for the words that can tip you off to the particular procedure that you should use. When you try to solve the cliffhanger puzzles each week, just what do you suppose you're doing? Surely you're solving a word problem. And speaking of the cliffhanger, let's answer the one from the last lesson right now. Last time, I told you that I had 2 U.S. coins in my hand. I also told you that these 2 coins total 55 cents in value. I said that one was not a nickel, and I told you to bear that in mind. Now, what are those 2 coins? The key to this puzzle is in the wording. In fact, that's the key to word problems in general. You have to read them carefully and think carefully to decide how to go about solving them. So, what's the key word or phrase in this puzzle? The key here is that only one of the coins is not a nickel. To approach this problem logically, you must first think of the different combinations of U.S. coins that can total 55 cents. There are several possibilities, such as 5 dimes and a nickel, 2 quarters and a nickel, 11 nickels, and so on. However, all of these combinations involve more than 2 coins. The only combination of U.S. coins that can total 55 cents and only involve 2 coins is the combination of a $50 and a nickel. Ah, but the puzzle says that one of the coins is not a nickel. That's very true. One of the coins is a $50, but the other coin is a nickel. Only one of the coins is not a nickel. The other one is a nickel. See how that tricky wording can trip you up? When you work word problems, you often run into wording that can confuse you if you don't think carefully. To help you avoid that problem, let's review some math terms before we begin solving word problems. The first word is sum. The sum is the total answer, or the answer that you get when you add numbers together. For example, the sum of 12 and 4 is 16. If you are asked to find the sum, then you know immediately that you must add numbers together. Combined tells you to add numbers together. 12 and 4 combined gives 16. As I've already mentioned, a total and a sum are the same thing. When you add numbers together, you get a total. The total of 12 and 4 is 16. The words sum, combined, and total tell you that you should add. That's easy enough. When you see these words in a word problem, remember that you are being asked to add numbers together. What words can tell you that you must subtract? Well, minus is a good example of a subtraction term. 12 minus 4 equals 8. Minus means that you subtract one number from another. The difference between 2 numbers is the answer that you get when you subtract. The difference between 12 and 4 is 8. Again, to obtain the difference, you must subtract. Less and less than can also tip you off to the fact that you must subtract. 12 less 4 equals 8. 4 less than 12 is 8. If it is a question of whether you subtract or not, look for the words minus, difference, less, and less than. When you see those words, you know that subtraction is involved in the word problem. How do you know when to multiply in a word problem? One word that will tell you is the word times. 12 times 4 is 48. The word times tells you to multiply. Here's another word that involves multiplication. It is the word product. You get the product of two numbers by multiplying them together. The product of 12 times 4 is 48. To find the product, you must multiply. What about division? If a number is divided by another number, you know right away that the procedure to use is division. Another word that we often see in problems is the word average. To find an average, you add and then divide. For example, find the average of the numbers 8, 10, and 12. First, add all those numbers together. The sum of those three numbers is 30. Now, find the average. To do that, you must divide the sum, which is 30, by the number of numbers that you added together to get that sum, which is 3. 30 divided by 3 is 10. 10 is the average of those three numbers. If you'll remember, this is the skill that we learned at the Alabama Sports Hall of Fame. Many word problems require you to do more than one procedure to find the answer. That last problem is a good example of this. To find an average, you must first add and then divide. But suppose that you are simply given a total and asked to find an average. Let's do a problem like that. A plane travels at 480 miles in 3 hours. What is the average number of miles the plane travels in 1 hour? How will you solve that problem? Well, let's see. If the plane travels 480 miles in 3 hours, we know that the 480 is the total, or sum, of the distances the plane traveled in the entire 3-hour period. So, to find the average number of miles that the plane travels in 1 hour, we must divide 480 by 3. When we do that, we discover that the plane travels an average of 160 miles in an hour. There isn't anything too difficult about that, is there? Try this one. My dog eats an average of 8 dog biscuits a day. How many dog biscuits does my dog eat in a week? Now here's a bit of a problem. Are you actually being asked to find an average in this problem? Nope. I'm asking for a product here. I told you the average in the problem. I want to know the product, the number of dog biscuits that my dog eats in a week. How do you figure that out? Well, first of all, you know that you aren't looking for two numbers to divide. If you divide the average number of dog biscuits per day by the number of days in a week, that isn't going to give you the number of dog biscuits that the dog eats in a week, is it? If you read a problem carefully, you see what is being asked of you. In this case, the word average is there to throw you off. What the problem actually asks you to do is to multiply the number of biscuits per day by the number of days in a week. So, you multiply 8, the number of biscuits per day, times 7, the number of days in a week. What's the answer? 56. So, my dog eats 56 dog biscuits a week. That problem could have given you trouble, but it did not because you read it carefully. Are you ready to do some more word problems on your own? Good. Let's begin with this one. The Birmingham Zoo has 3 polar bears. Those 3 polar bears eat a total of 180 pounds of food each day. How many pounds of food does the average polar bear eat in a day? What are you going to have to do to find that answer? First, decide what is being asked in this problem. You are told that there are 3 polar bears. Altogether, those 3 polar bears eat 180 pounds of food each day. You want to discover how much one bear, an average of those 3 bears, eats in a day. How do you find that answer? You divide 180 by 3. And what's the answer? 60. So, each bear eats an average of 60 pounds of food each day. That's easy. How about this one? The zoo train travels at a rate of 2 miles in 5 minutes. How long will it take the train to travel 10 miles? Okay, let's begin with the train's rate of speed. It takes the train 5 minutes to go 2 miles. How long will it take the train to go 10 miles? How many 2-mile trips will a train make during a 10-mile trip? To find that out, divide 10 by 2. Well, the answer, of course, is 5. If it takes 5 minutes for the train to make one 2-mile trip, how long will it take the train to make 5 2-mile trips? Multiply 5 minutes times 5 trips. The correct answer is 25. So it will take the train 25 minutes to travel 10 miles. Let's do an easy problem. A gazelle can run 10 miles in an hour. How far can a gazelle run in 4 hours? Now, you are given the number of miles that a gazelle can run in 1 hour. That's 10 miles. How do you find out how far a gazelle can run in 4 hours? Simple. Multiply 10, the number of miles in 1 hour, times 4, the number of hours. The answer is 40, or 40 miles in 4 hours. That problem is a simple matter of multiplication. Now let's do something that is a bit harder. Listen carefully. In 3 days, the zoo sold 120 tickets. At that rate, how many tickets will the zoo sell in 5 days? How do you solve this? Well, first of all, we have to find out how many tickets are sold in 1 day. To do that, divide 120 by 3. The answer is 40. So the zoo sold 40 tickets in a day. Now, how do you find out how many tickets the zoo will sell in 5 days at the rate of 40 tickets per day? You multiply 40 times 5. 5 times 40 equals 200. So at that rate, the zoo will sell 200 tickets in 5 days. By now, it should be getting easier for you to decide what you are actually being asked to do in a word problem. As you become more skillful, you can tackle more difficult problems. Let's try a more difficult problem to test your skill. Everyone likes seals. They're fun to watch because they're seldom still. They seem to move all the time. We're going to solve a problem that involves the pool where the seals live. And here it is. It takes 15,000 gallons of water to fill the seal pool. If the water is pumped into the pool at the rate of 15 gallons per minute, how many hours will it take to fill the seal pool? What's the first thing that you notice about this problem? The rate is given in minutes, but you have to find the answer in hours. That fact tells you something important about this problem. It tells you that you must do 2 different procedures. What is the first thing that you must do to solve this problem? You must find out how many gallons of water are pumped into the seal pool in 1 hour. There are 60 minutes in 1 hour, so you multiply 60 times 15, the number of gallons per minute. The answer is 900. So 900 gallons of water are pumped into the pool in 1 hour. Now, if the rate is 900 gallons per hour, how long will it take to put 15,000 gallons of water into the seal pool? To find out, you must divide 15,000 by 900. When you do that, you will discover that the answer is 16 with a remainder of 600. Now, just to be thorough, let's write the remainder of 600 as a fraction. 600 900ths can be reduced. The lowest common denominator is 300, so that fraction can be reduced to 2/3. So it takes 16 2/3 hours to fill the seal pool at that rate. That same problem can be solved another way too. You may have already figured this one out. You can determine the number of minutes it takes to fill the seal pool at that rate and divide by the number of minutes in an hour, which is 60, to get the total number of hours. Let's work the problem that way too, just for fun. If the pool is filled at the rate of 15 gallons per minute, how many minutes will it take to fill the pool? 15,000 gallons of water at 15 gallons per minute. Divide 15,000 by 15 to find the number of minutes it takes to fill the pool. Of course, it takes 1,000 minutes. How many hours are in 1,000 minutes? To answer that, divide 1,000 by 60. The answer is 16 with a remainder of 40. Since we're dealing with minutes here, then we know that the answer is 16 hours and 40 minutes. And guess what else? 40 minutes is 2/3 of an hour. How do I know? Write 40 over 60 as a fraction. The lowest common denominator is 20. So when you reduce that fraction, you get the fraction 2/3. Either way that you solve this problem, you are going to get the same answer, 16 2/3 hours, or 16 hours and 40 minutes. Here's another tricky problem that involves the seal pool and some decimals. The seal pool is filled twice a week. The zookeeper adds 1.5 tons of salt each time the pool is filled. How long will it take to use 12 tons of salt? I'll bet that the first question you have about this problem does not have anything whatsoever to do with the problem itself. You're probably wondering why the zookeeper adds salt to the water. The reason is simple. Seals live in the ocean, which is composed of salt water. The pool is filled with fresh water, which isn't salty. The salt must be added to the water to duplicate the natural saltwater environment of the seals. That makes sense, doesn't it? So, now that you understand why this is done, let's proceed with the problem at hand. There are two different steps to this problem, too. The first thing that we want to know is the number of times that the salt can be added to the pool at the rate of 1.5 tons per filling. How do we find that answer? Of course, we divide 12 tons by 1.5 tons. Don't forget to add a 0 and move your decimal points. Remember this? So, your divisor becomes 15, your dividend becomes 120, and your answer becomes 8. The pool can be filled a total of 8 times by using 12 tons of salt at the rate of 1.5 tons of salt per filling. If the pool is filled twice a week, how many weeks will that supply of 12 tons of salt last? To find out, divide 8 by 2, the number of times the pool is filled each week. You will find that it takes 4 weeks to use 12 tons of salt. Finding answers to your word problems is easy once you get in the habit of reading the problems very carefully and deciding exactly what you are being asked to find. Are you looking for a total, a product, a difference, or a quotient? Are you trying to find an average? All of these factors play a part in solving a word problem. Let's do one more word problem before we go on to the cliffhanger. The distance from the studio to the zoo is 6 miles. The distance from the zoo to my home is 3 miles. The distance from my home to the studio is 7 miles. If I travel from my home to the studio, then go to the zoo, and then go to my home from the zoo, what is the total number of miles that I will travel? How do you solve that problem? Well, what are you being asked to find? A total. So that means that you must add. Add the distance from my home to the studio, which is 7 miles, to the distance from the studio to the zoo, which is 6 miles. 6 plus 7 equals 13. Now, add the distance from the zoo to my home, which is 3 miles, to the total distance of 13 miles. For the other 2 trips, what's the answer? 16 miles. So I will travel a total of 16 miles. No problem there. You have no reason to be afraid of word problems. Just pay attention to what you're being asked to find. Decide if the answer is going to involve more than one procedure, and if so, decide what procedures to use. It's that simple. Why don't you sharpen your skills by using the cliffhanger for this week? Listen carefully. A farmer had 20 sheep. All but 5 died. How many sheep did he have left, and what percentage of his original flock was that? Work on that word problem, and remember not to let the wording cause you problems. We'll see you next time on Jump.